For the sake of readability and ease of use, the best approach to applying transforms to Torchvision datasets is to pass all transforms to the transform parameter of the initializing function during import. For the CFAR10 dataset, that would look like this. However, this will not yet work, as we have not yet imported Torch, nor have we defined the single object, labeled train transform, that is being passed to the transform parameter. The Torchvision.transforms class that allows us to create this object is transforms.compose. In order to use transforms.compose, first we will want to import Torch, Torchvision, Torchvision.datasets as datasets, and Torchvision.transforms as transforms. We also want to check that our installed versions of Torch and Torchvision are current. For use in this example, I will redefine the normalized transform. Now, I define the train transform as train transform equals transforms.compose with a list of desired transforms, starting with a random crop, followed by the 2-tensor transform, then followed by our custom normalize transform. Transforms.compose takes a list of transform objects as an argument and returns a single object that represents all of the listed transforms chained together in order. In this case, the train transform will randomly crop all of the dataset images, convert them to tensors, and then normalize them. As I mentioned, the transforms are applied in order. This is important because any transforms that take images as arguments, i.e. random crop, need to be listed before the 2-tensor transform, while any that take tensors as argument need to be listed after the 2-tensor transform, i.e. normalize. Once the transforms have been composed into a single transform object, we can pass that object to the transform parameter of our import function as shown earlier. And now every image of the dataset will be modified in the desired way.